Hey everybody, welcome back to my video here. We're going to talk about the very first lesson in chapter 2, which is solving equations that have rational coefficients. Now that's some pretty fancy language, but really all that means is there's going to be something, a rational number, usually a fraction or a decimal, but it doesn't have to be a fraction or decimal, that is being multiplied by a variable. That's what the definition of a coefficient is. If you need to see what that word looks like written on my board here, here's what I'm saying when I say the word coefficient. And what a coefficient is a number, I'm going to do the little hashtag thing here for number, a number being multiplied, has to be multiplied, not divided, not added, not subtracted, a number that's being multiplied by a variable, and the variable is just the letter in the question, right? The A, the B, the C, the X, the Y, the W, the K, whatever. And so there's the definition of a coefficient. And so all these problems will have a coefficient, something that the variable is being multiplied by. And if you know what the variable is being multiplied by, then we can work backwards to solve it, right? We've been working backwards all throughout our middle school career to solve questions. And if this is a multiplying situation here, the W is being multiplied by 4/7. In order to solve it, we could do the inverse, the opposite of multiplying, which is dividing by 4/7. Now, I want to show you something. Now, this is going to look a little bit awkward. How many times in your life have you seen this, right? Do you usually see a fraction divided by another fraction? Not really. Now, technically, anything divided by itself equals 1. But how often do we really divide fractions like this, vertically, up and down? We really don't do that very often, do we? What you've seen before in 6th grade and 7th grade and whenever it was, is usually you see dividing with fractions written horizontally, across, right? So you might have seen 24 divided by 4/7 like this, right? Now, I bet that looks a lot more familiar. You've seen a question like this at some point in your life before, right? And maybe they would have you put a 1 underneath there to make it look like the other one. Now, do we actually divide fractions? No, we don't, do we? A lot of people in our school have learned the acronym KEEP, change, flip, right? Where you keep the first fraction the same, you change the dividing sign to multiplying, and then you flip or use the reciprocal, right? The reciprocal of the last fraction. Notice what this was. This is the coefficient, right? The coefficient, whatever the variable is being multiplied by, always goes last. If you do not put it last, you are going to mess up your answer. Your answer will be upside down. And so instead of 4/7, we're going to flip this. We're going to do the reciprocal, or if you want to sound like a real smarty pants, you call it the multiplicative inverse. And then you have your problem. We all know how to multiply fractions. We've been doing this our whole middle school career. Some people who aren't the best with mental math, they would just go straight across. They would do 24 times 7, and oh boy, I'm going to test myself, see if I can do this. 168. They would do 4 times 1, and then they could, on their calculator, they could reduce this, divide these, and do whatever we needed to get the answer of 42. Some people would use that fraction button on their calculator to reduce the fraction. Some people might be looking at what I just did and said, dude, that was the dumbest thing ever. I know that 4 goes into 24, and I could say, wait, I can cancel this out here. 4 goes into 4 one time, and 4 goes into 24 6 times, and then they could do 6 times 7, which also equals 42. So you kind of have 2 ways to do the very last step. You can just go straight across and then reduce it, or you can try to cancel it and reduce it right there if you're a person who's pretty good at mental math. But I know not everyone is comfortable doing mental math like that. So that's how you're going to do these. You're going to rewrite the problem as a dividing problem. Instead of vertically, we're going to rewrite it horizontally. Remember, the coefficient always goes last. It's what you were dividing by, 4/7 and 4/7. Whatever the variable is being multiplied by, that goes last in your division problem. And so then that is the part that you flip upside down to do the reciprocal to actually get your answer. Okay, let's do another one just so you can see me do one more, and then I will move on to a different type that actually is a little bit easier. So let me pick one that is not as easy as maybe the first one. This might be a little bit more complicated. Not too bad. 5/7 C equals 13 over 14. Okay? I don't know this one in my head. Nobody in my classes knows this one in their head, and that's fine. I do know this is multiplying, and so the opposite of the inverse of multiplying 5/7 is to divide 5/7. And I have kids in my class, I have a few kids who really like to write it like this anyway, even though this looks a little bit weird, right? 5/7 divided by 5/7 is 1. I'm canceling it out because it equals 1. And then here, this looks a little bit awkward, and so we could rewrite this. Let's rewrite this as 13 over 14. Sorry, the marker still has some of that black ink on there, it wasn't writing. Divided by 5 over 7. Now that is a problem that you have seen in 7th grade and 6th grade all the way throughout middle school, and you don't actually do division with fractions, right? We do keep, change, flip is kind of the acronym, but honestly all it is saying is dividing by a fraction is the same thing as multiplying, change this to multiplying, by the reciprocal, right? The multiplicative inverse. And so this right here is a question you could do. If you have a calculator, this is a great opportunity to use it. If you're good at mental math, I know that 7 goes into 14 2 times, but maybe you don't. So you might just do 13 times 7, and that would give you, holy cow, 91. And then you could do 14 times 5, which I believe is 70. And then if you have a fraction button on your calculator, you could do 91 ABC 70, or 91 divided by 70. You could use the division bar, or the division sign. That would make it a decimal, and you could reduce it like that. But a lot of people in my classes today were saying, hey, wait a second, I know that 7 goes into 14 2 times, and so I would just have 13 times 1 on the top, and on the bottom in the denominator I'd have 5 times 2, and you could get 13 over 10, or if you wanted to put 1 3/10, that would be acceptable. If you took 91 and divided it by 70, you would get 1.3. If you don't believe me, look right here. If I borrow Mimi's calculator, hopefully she doesn't care. Mimi's going to get a little bit of a shout out here in my video. You can see right there 91 divided by 70 is 1.3. So all of these answers are acceptable. Do you need to do all of them? No way, Jose. Pick the one that is the easiest and the most convenient for you, and then go with that one. Okay? All right, the last type of question in this lesson is actually even easier than the ones that we've done so far. Sometimes they'll give you equations that look like this. This is a letter T, that's not a plus sign. And this is also a version of a rational number, except now instead of fractions, now we have decimals. These are even easier. This is when your calculator can come in to shine and be the MVP of this question, right? This marker does not like to write. I'm trying to put a multiplying dot in there, right? This letter T is being multiplied by 0.4. So if I want to solve this for T, I'm going to have to undo what's happening to the letter T. Instead of multiplying by 0.4, I want to do dividing by 0.4. And whatever you do on one side, you need to do the same thing on the other side to keep it equal. Here, anything divided by itself equals 1. Just like on the last one, anything divided by itself equals 1. Same idea right here. That goes away, and this is your answer. There's no need to do any keep, change, flip. There's no need to do reciprocal when they're decimals. When they're decimals, you just take Mimi's calculator, if you happen to have it in front of you, and you do 0.72 divided by 0.4, and you actually don't have to type that 0 at the beginning if you don't want to, and you get the answer 1.8. T equals 1.8. Easy. Done. Right? So don't let these decimal ones make you confused. I think the decimal ones are my favorite because there's no need to do any flipping. There's no need to do any of that stuff. I can just go straight into the division. Let's do one more. When they decide to be really rude, look what they could possibly do. They could possibly give you some negatives, and then this one is double rude because look, they wrote it backwards. See how the letter M, the variable, and the coefficient are at the end after the equal sign? Usually they are in front of the equal sign on the left-hand side of the problem. Don't let this bother you. We can still do it. This is still multiplying by right here, isn't it? The letter M is where my eyes are focused. I always look for the variable. That's going to be where the action happens. So right here, my letter M is being multiplied by 0.04. I want to undo that. So the inverse of multiplying by 0.04 is dividing. This marker is just not working today, so I'm just going to give it up. I don't know why I keep trying. 0.04 is dividing. It's going to be our inverse of multiplying. So whatever I do on one side, I do the same thing on the other. Boom, right there. Anything divided by itself equals 1. Mimi's calculator is going to come to the rescue. You should know when the signs are different, our answer is going to be negative. If the signs were the same, like if they were both negative, then 2 negatives would make a positive. But if there's only one negative and the other one is a positive, I know my answer is going to be negative. And so I'm going to do negative 5.2 divided by 0.04. And my calculator spits out, whoa, a big number, negative 130. Negative 130. I'm going to write that down. I'm going to put equals m. Don't let this fool you. If this really hurts your brain, could you flip everything around and say m equals negative 130? Is that the same thing as this? This and this? That's the same thing. So don't let that bother you. So there's our answer. M equals negative 130. Now, if I really wanted to check it and I wasn't sure if I was doing it right at my house, and I'm like, man, I don't know if I'm doing these right or not, could I take my answer and take it all the way? I'm going to give this blue marker one last shot. Could I take it and put my answer right back here in the original problem? Could I do 0.04 times this and see if I get negative 5.2? Well, of course I could. Look, 0.04 times negative 130, and look what I get, negative 5.2. That's exactly what I had up there. So you can use your calculator to help you check your answer on these if you ever need it. Okay, guys, that's going to be it. This is about an 11-minute video, so I feel like this is about enough. I'm going to put some questions maybe on the Google Classroom, and if you have any issues or you need help finding them, let me know. If you don't see anything on the Google Classroom or on the McGraw-Hill site, don't worry about it until I make an announcement about it. All right, see you guys later.